Yeah, my name is Camillo. I'm CEO and founder of MLReef. We are an Austrian startup working on MLReef since around two and a half years now. It's an open source project, so please feel free to hop into our GitLab and GitHub repositories, see what we are doing, contribute if you like what you see. With me is Erika. She's our head of AI. Maybe you can present yourself as well, just briefly.
Hey to all of you. I am the head of AI in MLReef, working with Camilo since 1 year ago. And we are developing this platform with a very cool team from all over the world. And hopefully you're going to enjoy this presentation. Thank you.
Yes. So, just a second. Okay, good. So we have prepared a little presentation. It will not take more than around 5 minutes for you guys to understand the concepts of MLReef and what we think will MLReef do and what problems MLReef will solve. As I said, feel free to give any questions in the meantime. Happy to answer them when they pop up. So to start with, as I said, MLReef is an open source platform, which is Git-based. And what we provide is the end-to-end development environment. A speciality about MLReef is that the users themselves provide whatever they need, all the tools and services. We just make it easy for you guys to explore it and to reuse the content that others have made. And all this within a very collaborative and reproducible environment. This sharing of content and this collaboration aspect is sort of the name giver here as well, the reef of MLReef itself. So a habitat where different users can interact to each other and synergy effects can happen. How this will work, we will show that later on in the demo. On a more technical side, our objective was to design MLReef based on the best practices on DevOps itself, and known already from platforms like GitHub or GitHub. So this means concurrent workflows in source code, for example, Git-based reproducibility, and different CI/CD mechanisms to make it really easy and automated to deploy and to work within a team. And what we are doing, we are adding machine learning specific functions on top of that, which is basically the pipeline management. It's the publishing process, which is sort of a modular containerization of your scripts, and model tracking and management. A little bit later on in the roadmap, we want to have the deployment phase as well, but we decided that this aspect, so the data management and the experiment management, is sufficient at the beginning to start with. What we are trying to do here as well is to drive a little bit of a paradigm shift away from unstructured and notebook-centered machine learning development, which can be sometimes a little bit overwhelming, unstructured, inefficient, to a more modular MLOps, which means that you can work concurrently on pipelines, on code, on data, and which is in the same time transparent and collaborative. And all this making it very easy, but also very, very flexible at the same time. So this was a little bit our task when we started. MLReef is a unified solution for the entire machine learning lifecycle. This is our credo. This is our objective that we want to build. And all this built from ground up as a single application. What you can see here is sort of the different areas that we are already covering, and with the little circles in there mentioning the maturity state of the different functions. So it's really from managing your project itself, your team members, your resources, creating the different projects and working with your data, building pipelines, creating experiments, and also sharing the work that you have been doing within the organization, across the team, or even just by yourself. And the last part is the serving, which is still on the roadmap, as I mentioned. So why MLReef? We really believe that we are the platform that enables super fast prototyping. You will see how this is done. And this is, in my opinion, one of the crucial aspects in machine learning development, especially for those that really are starting. When you start a new project, you really want to come fast to results, and not only one result, ideally many different, from many different angles. It allows in-depth collaboration to a new level, and it's also an effortless mean of sharing your work that you have been doing. Based on Git, it's very granular. You have very granular reproducibility, complete ownership. It's open source. All projects there, if they are not private, are also open source. You have complete ownership of what you're doing, and thanks to Google at the moment, also free cloud computing. So where are we today? As I mentioned, our team has been building MLReef since around 2.5 years now. We launched MLReef around or by the end of last year, and since then are measuring, validating, optimizing, going back in loops and loops and loops, especially with the thanks of our first users and clients that are using the platform. That's extremely helpful. So what are we going to do today? And hopefully I'm going to quit that GB Jabber. So we are going to train a multi-class bacteria model for a classification task, image classification task. You see here a little bit the subclass or subtask that we will be doing. So discovering and managing your repositories, source code management, publishing of code modules, which is a very important part of what we're doing, and understanding a little bit the CI/CD principles that underlie in MLReef. We will do data pre-processing as well, concurrent experimentation and iteration. This is a cool part that I'm also very much looking for. And then seeing the results in the experiments and the performance, and yeah, ending up with some insights and user management. So I would say we jump straight into it. So I'm just seeing if you have any questions, please just write them down. Happy to answer them. So we will start with the dashboard. The dashboard is basically where all your projects are. MLReef is what you can see here now is MLReef.com. So this is our hosted version. You can also use MLReef locally on your laptop or on your service. It doesn't really matter. The difference, obviously, is then that all the public projects that are shared on MLReef.com, if you are using it locally on your service, obviously will not be there. But this is a means of creating a knowledge base as well. If you are an organization, for example, and you want to really share the work across teams and across the entire organization. This view probably is very, you will know it. It's nothing very special. You have public projects, and then you have obviously your own repositories as well. And yeah, there you have the differences between public and private projects that you also know from other parts. The special thing about MLReef, and this was the idea when building the platform as well, is that we want to take a more modular approach into machine learning. So we have different building blocks that you can use as sort of Lego bricks within your machine learning lifecycle. On one end, you have the machine learning projects. This is where the entire magic happens, and we will come to this a little bit later. And then you have here what we call code repositories. So they are Git repositories specifically for a function within the machine learning lifecycle. So this is obviously for training models. This is for data operations and data visualizations. I will jump now to one repository that we created before, which is called Bacteria Classifier. And when you enter, you already get the feeling of Git. This looks a little bit like GitHub, and this is also meant for it. So you know that you have to use Git in order to push whatever you have, your code and so on. So the first thing that I want to do is fork this project. You can, by the way, do the same thing. We shared the link to this repository. Yeah, depending on the size, this might take a couple of seconds, a couple of minutes, or maybe if the data set is quite huge, a couple of hours. But joke aside, now this is my repository. And I mentioned one thing that is very unique, and what we are aiming to do is concerning fast prototyping, is encompassed within the publishing process. I will do this now. The publishing, what it does, it containerizes your script. It reads out the parameters that you have annotated within your script. I will show that later as well. And it will also include all the dependencies that your script requires, including a base environment. How this looks like is quite easy. It's basically a wizard that you click through. You define your entry point. You can select here a branch as well. You select the base environment. At the moment, we only have one, but the idea is to open this up as well in the near future. Click it through, just select the model type, what it is for, and that you can send that the entire community can use your scripts in the pipelines itself. And then that's it. The publishing starts, the containerization starts in the background, and hopefully soon you will end up in a view where you can see, okay, the publishing is going on with the job log to seeing, okay, what exactly is happening. I will also show something that is quite nice as well that we added just briefly. You can see here the source code itself. This is, I think, a mobile net, if I remember correctly. It's based on Torch, so it's framework independent. You can use whatever you want to. In this case, we are now at the moment still bound to Python, but the idea is to open it up to other languages as well. And a very important aspect at the very beginning as well is that we really want to be non-intrusive. So we don't have any library. The script itself works wherever you bring it. It's only the libraries that you specify that you need. The only thing that we require is parameter annotations that you can see here on top of that. And that's basically it. The rest is really the normal code that you are already used to and would work with. So what I'm going to do now is adapt a little bit this original script that Erika has made and include another annotation that I want to have in here. I cheat a little bit because I already copy-pasted it somewhere. But I'm going to include a weight decay, another parameter that I want to be able to address in the pipelines. And the annotation itself, yeah, it's quite easy and understandable as well. You have a name, so you give just the parameter a name. You have a type, in this case, it's a float. If it's a required parameter or not, if it has a default value, and you can add a description in there as well to make it easy for your team to later understand exactly what this does and so on. The weight decay parameter obviously is described down below here as well. It's via argument parser and in the script down below as well. I'm going to add here a description, add, how I call it, weight decay. And I'm going to rename the branch like this, weight decay, and I edit it. So, what I have done now is exactly that. You can see that I have the branch here. What I can do now as well is I just simply will push the new branch that I created and publish it, this branch as well. The same procedure as before, bacteria classifier, taking the base environment, selecting what it does, as a CNN and a classification for a classification task, and a consent. And I publish it. Okay, an error, it has still pending jobs. Okay, we have to wait a little bit until this publication is through. Good to know that this is not working yet. But nevertheless, I think you get a little bit the point how this is working. The idea is really that you can work on different versions at the same time, and using those then within this Docker registry, within the pipelines to run your different jobs. So, having seen that, I'm going to look at you as well, if you have any questions in the meantime. Okay, I'm zooming in a bit. Yes, I can try. Is that better? I guess so, huh? Okay, cool. Good. So we're going to jump now to the machine learning project. I'm going to just search for it. It's the classification of bacterial species. This is the machine learning project. It's not the model itself that we just operated in. When I enter, I have the Git repository as well, so you can upload your data using Git. This is for now the only way of uploading data to a repository or to using data within the pipelines. We're working currently on data connectors as well, so you can use 3 buckets or even attach your databases directly to the pipelines and use data streaming mechanics. In this case, as I said, we want to classify bacteria. I personally have no idea about bacteria, but what you can see here is the data set. You have then, in this case, 9 different classes of bacteria. In this case, it's TIFF images. And what we want to do is really, iterate fast, train fast on recognizing these little creatures and creating a medical application for that. I'm going to start with, what you can see here is that we have different tabs. This first is the data tab. Here you do the data management. And this was an initial idea as well to really give a little bit more structure to the machine learning process, not as a monolithic approach as you're often used in notebooks, but you have operations or pipelines that are for example, in this case, data preprocessing or data visualization. The concept behind is that if you have a team, for example, and you have field experts that know a lot about data but have no clue about data science itself, they can work very simply using these pipelines to pre-process the data to generate new data sets, where then the handover is quite easy to the data science team that can work on the scripts, adapt them to their needs and run experiments and so on and so on. So what I entered now is the data pre-processing pipeline itself. It looks quite simple. So you would start by selecting an input path. So selecting the data that you want to pre-process. I'm going to stay in master, and I'm going to select the entire data folder in here, and I accept that. And then here on the right side, you see all the published data operations that the community has done, or in this case, also your team, whoever has done it. And by I will add now noise, by a simply drag and drop, you can use then this prior published data processor in the pipeline itself. Through the annotations, you can read out the parameters. I can write something like that out here, for example. So this will take the data from the data path and add some noise. I will add salt. I know that this exists. If you want, also you can see the code, review it, see how it works. Or if you click add noise, for example, you will jump directly to the repository that in this case also Erica has made. And yeah, you can do the same thing again. Fork it, change it and adapt it to your needs, publish it, and reuse it here in this pipeline. What you can do here as well, this would be quite simple just to have one operation, right? So we wanted to enable concatenation as well. So you could just use, for example, I don't know, let's use a random crop, for example. You just drag and drop it as well. And what this pipeline now does, it executes the first operation first and then the second afterwards. So by defining input path and output path, you can play around a little bit. So you say the images first pass the add noise operation and are stored in output 1. If I would leave this the same way, the second operation would go in parallel and you could also define this, for example, like that, and would also store the output in the output 1 folder then within a new branch that will be created. But I want to do more concatenation in this sense. So I will use the output data that was generated before in the output path 1, and this output path, and call this final, for example. And I don't know, let's put some values in here and some values there as well. And yeah, it's simply as that. And you can just execute this pipeline. You select the machine and execute, and yeah, proceed in this case to the results. So what this does then, it spawns a runner in the background and creates this job. In our case, we are hosted on GCP, so on Google. It spawns a dedicated machine for this job, and yeah, uses all the Docker images that have been created during the publishing process and installs them in this machine and runs the job throughout. You can access them. Okay, I'm going to jump now to questions because now I'm seeing that. I'm going to answer, Andrea, your question first. This is up to your will. I mean, you have complete operational freedom. The question is if you need one repository for each function, or you can have yeah, multiple functions within one repository. What we want to do is really differentiate between the basic function of your script itself. So what does it do, basically? But at the end, it's Git repositories, it's Docker images that are created, and the publishing process takes only one entry point of your script. If you have different functions within your scripts and different files that do different functions, for example, and you can address them via parameters for your entry point, well, you can do whatever you want to, basically. Do you support other clouds like AWS and Azure? Yes, we do. We were sponsored before by AWS, so we moved now to Google Cloud. We are running on Kubernetes as well. You can also use MLReef on-premise. We even have a complete offline mode for MLReef, so yeah, no internet connection required for that. What you can see here as well, if you enter one data or this data pipeline, that this now is running. You have git commit hash in the background. So you would see it here, for example, that what exactly are you using, for example, what kind of data, what version of data you're using. You can review the status of your pipeline. So what exactly is it doing? Debugging it and visualizing it. You can see exactly what data operations you have used, and if you click View Pipeline, you can see exactly the pipeline in the state that you have created and execute it again if you'd like. So this is pre-processing. The same works very similarly with data visualization. And I'm going to now jump to experiments. And this is a little bit more the fun part. I'm going to create a new experiment for that. Same topic here. I'm going to select the data that I want to use. I could use a different data set that is now running, but yeah, I'm going to use master in this case. And we have here the bacteria classifier. So I'm going to search for that. And you can see we have two. One is the original one from Erica that she created, and now mine. And the same thing, with a simple drag and drop, I can put it in there and yeah, just fill out and address the parameters that I want. I know that it's 9 classes that I want to have it pre-trained, so select true, and the number of epochs, let's say 15. What I can do as well is sort of search for other models that might fit. So let's call image, for example, and yeah, use this basic tutorial model that we also have in order to train 2 models at the same time. I can fill this out, output like this, and just use it. And what is it? I don't know. I have to fill that out there. Sorry for that. Erika, do you know what parameter I need to put in the class mode? Ah, she's not there. Okay, I'm going to put something and get an error, probably. So, good. And the same thing again, execute, select the machine, and execute the pipeline. What I can do as well is easily go back, return to the pipeline view. And if I want, I can adapt my the model that I want to train. What I can do as well, for example, I can copy it, train the same here, but with other parameters, for example, just 10 epochs, different batch size, different learning rate, whatever it is. The cool thing here as well, if it had worked before to publish a separate branch, I could address a separate branch as well. I know that Erica's version, for example, has now 7 versions of its master published. These are all available Docker images of her code stored in the registry. And I can iterate with that. I can try different versions of her and seeing, okay, how exactly do they work? What kind of difference is there between that? Yeah, and I can execute this same experiment again and proceed to my results. And this is what you do then in experiments tracking. So we are writing down out all the performance parameters within all the experiments. So down below here, you see the experiment list. This is your experiment table, basically. And every experiment that you created before, you can see it here. It's stored. You can customize the columns, for example. So based on the epochs or floss or whatever it is. And you can open one up, see a little bit more details about the experiment, seeing what data you have used, from what branch it does the data source from, what kind of model you have used, the relevant publication, the hyperparameters. But you also can go a little bit deeper. If you click that, you can see the entire parameters that you have defined within your script. You can rerun the experiment always here as well with a view pipeline. You can see the training log. So as you see, it's running on Kubernetes in this time. And yeah, using, if you want to, you can debug and see what exactly happens. And also all the artifacts or the output of the model is stored as artifact, as well as, and that's something that you can decide, as well as a new branch that it will be created. So this is something that you can then access and download it and see exactly how your model performs and deploy it with for now, using other services. On top of that, you have the possibility to compare all experiments to each other and seeing how do they perform. You can add different values here and reviewing exactly how are they performing. If you say, okay, you know that there's one model that you really don't want to have in there, but you don't want to delete it, you can simply use it as well to just hide it. For example, this clever Warhol, we don't want to use it anymore, and yeah, compare it like this. So this is the experiment tracking part as well. You have obviously all the insights, so all the machines that are currently running and all the pipelines that are currently running. By accessing them, you can see the state of what they're currently doing. As I'm not the owner of this repository, I cannot manage any teams, but there is also the possibility to add new teams to your repository, give them permission levels, different ones. So for example, they cannot change master branch and stuff like that. That is the demo so far. So if you want, you can always book a demo with us and have more talks if you want with, just write us an email at hello@mlreef.com. Yeah, you can test it out yourself at mlreef.com if you want, or just install it and go ahead with that. We have docs where you can see how exactly this works. Yeah, that's all from my side. If you have any questions in the meantime, please feel free. Okay, there's one question, Andrea. Yeah, I think Erika already answered that. By the way, I'm going to try in the meantime. Thank you for us. In the meantime, I'm going to try to publish my model again that I wanted to. Let's see if that is working. I think this time, yes. Okay, this time it worked. It is really because the other one was still pending or running. So this is something that we need to include still concurrency. Is there any feedback, or if there's any feedback you want to give us, any opinions about our approach, or even tell us your necessities and your feelings that you have with machine learning, your experiences, please feel free. I mean, feel free to do it here and right now, or just reach out to us at any time. Yes. Is there something specific you want to see? Yes. Sure. Let's jump back to our Peria project. So the current state is that you're using, or that sort of you are forced to using Git for your data handling itself. So you can use, you can store your data sets locally and just push your data to the repository via the git clone command. And this is where you have it then. The data ops, the data preprocessing pipeline will create, as I mentioned before, will create a new data set in there. So, and this new data set is stored as a new branch in here. So this one, for example. And this one created this output directory with new images and whatever you have done before. So this is a mean where you can then, just work on the data, and it is really, we're agnostic of what kind of data you're using, if it's image data in that case, if it's tabular data, or whatever it is. But you can use the different branches in order to work. Okay, so error, good. I don't know what that means. So you can use that for managing your data. The same or very similarly is with data visualizations. So you can create more complex visualizations if you have, for example, image data, which is not easy to visualize. And if you want to understand its composition a little bit more deeper, you can write your own data visualization script, publish it using any libraries that you want. Using that, and the output that you would generate is the same. It's just, I don't know, an image or some file that you want to use and use to understand that. Everything there, what you have is stored in branches, as I mentioned. And if you want to push the changes that you have made in one branch to the master, you can do it through merge requests. I mean, this is how GitLab does it. The idea, as I mentioned before as well, is this is something that we're currently working on as well, is using data connectors. So you can use different data sourcing mechanisms to import your data or use the data via data streaming within the pipelines itself. I'm not sure what exactly this 500 internal issue comes and pops out. But yeah, this is hopefully this responds a little bit your question. Any more questions or comments? So by the way, just because we're having these errors all the time, we're still in beta, just that you know. I think nothing critical should happen then also now. What we also wanted to do here is to make it quite simple as well to discover new things. This is something that I wanted to mention as well. So what you can see here is that when you create a new project, for example, if it's a new machine learning project where you put your data on, or even if it's a new model in your data operation or whatever it is, you will be asked for a data type. And this is something where you define, okay, what is your input data type that you're using for explorative tasks. So when you launch a pipeline and want to use others from the work from someone else, you just say, okay, I'm in need of image data preprocessing operations, for example. You filter by them and you use whatever you are having in your disposal. We also created, just to mention, small tutorials, which you can access here if you'd like. So these are hands-on tutorials that will guide you one by one through the process itself, and where you can really learn the basics. Yeah, hopefully this also helps you a little bit in the onboarding process. So, nothing else. If that is it, I would say thank you very much for listening. Hopefully, you had a little bit of a feeling where we stand now and what you can do already with the platform. If you have any feedback you want to send us later on, please just do. Thank you very much. Okay, I'm going to say bye-bye.